So today I'm going to share with you how to use the history, the object history in Dragonfly. Maybe something new. Um, I think it will be very useful most of the time. So you see, I have a data set here loaded. I could do many things with the data set, right? Like segmentation, visualization, analysis. Very often we will do segmentation. I will show a workflow. um, every time the workflow may be different for your task, but I show you a typical workflow we do, then we see how we can repeat that, how we can make the workflow as a macro, and we can reuse the macro for the future. Before I make a ROI for segmentation, I could crop the image first. So you see, I have the clip box. I don't want such big volume. I want make it smaller, so I can use my clip box to clip my views in 3D. You see the clip box, the borders changed at the same time. It's one clip box shown 2D and 3D, so they are synchronized. So I can change my border in 2D or 3D. After I get a good area, I could crop it. So we use the crop menu, which is here, modify, transform, crop. In the clip box, the position of the clip box has been copied here, which means if you change here, you see the numbers change here. So this is for cropping, which is create a new object, a new image file, image dataset. If you check this, create new. So now I have a new dataset, which is only the area in the clip box. Okay, now I have done one thing. I'm going to do the second thing is to create an ROI. And now I have to choose the geometry. I want this ROI to work with the cropped volume. So I change this geometry. This is like the reference for the ROI I'm creating. So I'm using the cropped volume as my geometry. Now I create an ROI. Next step, I can do some segmentation depending on what we want to do. For example, I want to get the range for the intensity in this cropped volume. I want to segment. Let me show this the maximum view. So I want to segment the particles, the powder particles here. So I found a good range. This is a manual adjustment for the range. We can also use, well, if I think that the range is good, is what I want, I can add all this to the ROI. This is what we normally do with the stretch coding, the manual stretch coding. And I'm not going to use this. I'm going to use a tool called O2. Where is it? Oh, it's here. See, we have a button here called split at O2. But now it's gray because I have nothing in my ROI. It's empty. I need to add something to my ROI. In this case, I add everything. So I use the full range. I add everything to my ROIs, or my ROI is full. But you don't have to use the range to make a full ROI. You can also use, if we don't use the range, if I undo, I can just re-invert. It's the same thing. Because before inverting, the ROI is empty, 0 labeled pixels. When I do invert, it has all the pixels labeled for this ROI. I do this because I want to use this button. I want to split the ROI to two different faces, the background, the foreground and the background. Now you see the button is great because the image is not correct. It has to use the image with the same geometry. Now it should be the cropped volume, because also will decide the threshold based on the intensity of an image, right? In this case, it's the image of the of the powders, the grayscale images. So it has to choose an image for the reference. Now I can split at O2. When I split at O2, I get two new ROIs. One is foreground, which is a higher intensity phase. Another, of course, is the rest, which is a lower intensity phase. What I'm interested in is the foreground, the high intensity, which is the particles here. And now, so I'm keep doing my workflow, right? I cropped my volume, I create an ROI, I used the O2, and the next step is if I do multi ROI, which is the um, instance segmentation, we know it already. Like the ROI now we see is a semantic segmentation. It labels all particles as one class. But my goal is to separate all the powders and see see each of them as individual class. So I have like measurement for every single particle. That is instance segmentation. And when we do that, the first thing is to use the connected component tool. So this is the way to create, this is one way to create the multi-ROI by connectivity. But if you use this already, we know if some particles are connected, for example, here, this will be labeled as one class. So we can see all these particles will be labeled as one class. And that's not what we want. So this is a very common issue. And normally we use watershed to separate them. You probably know this already. To use the watershed, we need to create the seeds. And in order to create the seeds, we always use distance map. But I'm not going to use that for this demo. So this demo is not about watershed or segmentation or instance segmentation or multi-ROI. So I just want to demonstrate a workflow, any kind of workflow as an example. The point is how we can repeat the same workflow. So what I'm going to do now is make it simple, more simple than the distance map. I erode this ROI. This is easier to understand. So I erode this ROI to make it smaller. You see it's getting smaller now. If I erode it multiple times, it will separate many particles. The touching edge, the touching surface will be broken. It's not as good as distance map, but it serves my purpose today, which is a workflow. So after I made a few times erosion, I get my ROI ready for Dragonfly. Oh, I'm sorry, for Watershed. So now I need to create a multi-ROI by connectivity now, because they are most of the particles, the touching particles are separate now. So I can use the connectivity. I use 6 connected. Okay. Now we see this multi-ROI is from the eroded version of the particles. You see, there's still some connection here. This is not Well, maybe if I erode a few more times, it will break this. But this is another point for today, so I just keep it like this. The next step is I want to use this multi-ROI as a seed for watershed. So it has like 160 classes. After watershed, I will have also 160 classes, but each class will grow to the edge of the particle. That's okay. That's why I should keep my original particle ROI, because I would use that again as a mask for watershed. When I do this, didn't I erode my ROI, so I don't have the original copy of my ROI. Okay, to get it back, I'm using the background because I don't need the background ROI now, so I invert my background. So I will use this as my mask. This is the same as the original, the particle ROI, the blue ROI. Now I also need to create a landscape image for the watershed. Normally it's okay, this image. Normally it's the age enhanced image from the original image. So I open the image processing. I'm going to use the Sobel filter, which is for edge detection. So my input is the cropped volume. If I do preview, you see this is Sobel filtered image. It has much higher intensity for the boundaries, the edges. I'm going to use this as the landscape for watershed. So I'll apply this filter to the whole volume. After that, I close this panel. Now I have everything ready for watershed. This is my landscape. This is my mask. And this is my seeds. Now I right click this, I get watershed transform. I need a landscape, which is a Sobel image, filtered image. The mask is my background now. Remember, I inverted my background, so it's now my background is the particle. So I do this. It's computing, that's expanding ROI, meaning every seed will be expanded to up to the edge of the mask. And for two seeds, separated seeds, you see here, the watershed will find the edge for two seeds. So those two particles are separated now. Before they were touching to each other. Okay, so now I get the final result, which is this multi-ROI. And of course, it's not very good. I said before, some touching part is not separated only because my seeds are not separated very well by erosion. I don't know why this two look separated, but maybe they just the same color. These two look like separated to each other, but see, to get a better watershed, you have to use distance map. Now, if I right click my final result, which is the multi ROI after watershed, I have a menu said extract object history as a macro. In fact, this menu is available for every object. For any object, you can right click and see the last menu, which is the extract object history as macro. If I do this to my final object, I I will be able to see all the history. So do you want to open the macro player? Yes, because it will, this menu extracted the history of this object, like how I created this object, all the steps, all the previous steps. So we can see from here, you see there has like 90 steps. Well, um, that's all the operations. Like first is the publish. Publish is to make some object visible in the list. So maybe I think this one is the first one, which is the publish of the original volume. Then you some steps are not very helpful because they are just set the visibility. Like we set the um, uh, if one object is visible in 2D or 3D, and we set the window level for one object. So some of them are for visualization. Probably they are not very helpful for us. They're not useful for us to when we repeat the workflow, because when we repeat workflow, we don't need to see everything. We just want the result. So we can see what is useful here. There's many here about about the visualization. You set the window level, set the color range, set the opacity, set the visual box. Oh, the visual box you see here is the clip box. So this steps, because I adjusted my clip box. If you remember in the beginning, I changed the border of my clip box multiple times. So you see, for every time it recorded, it's saved here, all the options. Or here my adjustment of the clip box. Now this is the crop. I cropped the volume. So up here it's the operation I did for cropping, and I get a sub volume. Now, and after that I published. So the sub volume, the cropped volume published here, so I can see it in the list. And visibility again, and there's some leveling. So this is the range. I think will be one step for oh, this is add range. I tried to add a range, but I did undo, so everything's saved here because I didn't use add range. I used the auto, so I reversed from the empty. I get a full labeled voxels as my RY. Then I used the auto. Oh, here split at auto, and I published my two RYs for ground background. See, this is the erode I did a few times. After that, I create oh, I published a new one because that should be a multi RY. I reversed the background to be used as the mask. Okay, so this should be the Sobel filtering, and you see the last one is the compute watershed with mask. All right, so we can see all the steps I did to create this object was saved in this macro. The good thing is we could reuse this macro. I don't know how to rename it because it's not, the name is not perfect. So I want to rename it. I can save the current macro as a new file, or save the change. save the change means we can make the change to the macro in the macro player. For example, we can delete some steps which are not very useful. Um, if we want macro more readable with less steps, we can delete all the unnecessary steps. And also some of the steps we have to specify some parameters. If we want to make change, we can change here. We can also change by the editor. If you click this is um, for opening the macro in the editor. So I have this button associated with my notepad. So it use notepad to open this macro. You see the Python code for this macro. You can, if you know how to program in Python, you can change this. You can modify this in the editor. After that, you just need to refresh, save, and refresh. Create new. So I'm going to save this as a new macro. I just don't know how to rename this to a better name for the macro so I can find them quickly next time. You see, I have already saved many before. Okay, let me just save it for now. I should overwrite. Maybe it's already auto-saved. I don't remember. So we try to remember the name of this macro. Then after I close this, I think I could use the macro to repeat all the steps automatically. So for example, if I delete everything I did, I'm going to delete it now because I'm going to repeat everything by the macro. I right click my volume. So there's execute macro. I think this is the one I just saved. I'm going to click this. Oh, it's working. So you see everything crashed. No, it's not crashed. It just finished and okay. Let me check. So it repeated my cropping here. I hide my it's repeated my cropping and create new ROIs and the O2 and the watershed. This is not correct. This should be the so well filtered image. Okay, this one is not correct. I don't know why. Maybe doesn't look like this one is totally wrong. You see the size. So the macro is not working properly for this step, which is the step for creating the landscape for watershed, which is the so well filtered image. So of course, if this step is wrong, the next step, the multi ROI is also wrong. The watershed is also wrong. Up to here is I think up here is correct. So this and this, the seed. Okay, now I need to find out why my macro has some issue for reproducing the Sobel filtered image. For that part, I probably not able to do it today. I can take a quick look, but I'm not sure if I can correct that or not. Maybe it's an issue we should fix by our developers. So I will report this to our developers as well. before that, let me see if there's anything I can do here. So this one is to title Sobel. This one added the filter to the operation, the image processing workflow. Okay. All right. I don't think I could find the reason to fix it now, but I'm going to talk to our developers and find out the issue. Maybe I can present this to you next time. And also, in this month, the last two webinars of this month, we are going to show macro builder. Macro builder is another way to create the macro. So what you have seen is to use the history of an object as a macro. We can also use the macro builder, which is a totally different way to do that. It's more like programming from beginning, from scratch. So we could program our new macro for anything. We just started um, from very beginning. We decline variables. We use some iterations. We do some actions, menu method, like the method call of an object, like an ROI is an object, or multi ROI is another object. Every object is a class, so it has different methods. We're not going to talk about today, but next in the as I said in the last two webinars of this month, we can show you how to program by using this tool. It's called Blockly. It's a programming, but without writing the code. So I'm going to read the questions. How Eduardo says, how do we define generally define landscape and mask for watershed filtering? Well, for watershed, we normally use an image which has higher intensity on the edges, on the boundaries. So very often we filter the original one because the original one we see from here, the yes, the edge is there's a big gradient of the intensity on the edge, right? But the original image, the grayscale, you don't see the edge as a ridge. For landscape, we say it's as a peak. So the watershed is not able to find the edge very well if it's not as a peak. So when we do a Sobel filtering, it will, as we see as we saw previously, we see the boundary has very high intensity in a Sobel image, filtered image. This is not correct, so we don't see it now. The mask is where, if you don't use mask, the seeds will grow it to everywhere in the image, like here. The seeds will grow. Actually, this is the seed. Oh, this is not correct. the seeds will grow to everywhere, meaning you need have a seed in the background. If you don't have a seed background, these two seeds will grow and they will grow and touch somewhere here. So if we use a mask, let me see, if we use a mask like this one, the yellow one, if we use the mask, then the seeds will not grow out of the mask. So it will stop here. Like this seed will grow up here and it will stop. If we don't use a mask, it will grow everywhere. Then if you have a seed in for the background, that's okay, because that seed will grow and to meet this seed at the edge. But in my case, I didn't have any seeds for the background, so I used a mask. So it's the same. If you don't use a mask, you have to add a seed. I could do that if I add, for example, if I erode my background, this is my real background. If I erode a few times, so if I had this yellow ROI as one more seed, so this seed will present all the background. So it will, like this seed will, the yellow seed will grow and the pink seed will also grow. They will touch each other at the edge. In this case, I don't need the mask. I could apply the watershed in the whole volume. So this is a topic about watershed. We can talk about the watershed again in the future, how to make it work. May we have a session on macro builder or macro maker? Yes. Movie maker, yes. Macro builder is very practical for batch processing. That's why we have already set up 2 sessions for macro builder in the last 2 weeks, as I said, in August 17 and August 24. We'll talk about the macro builder, and my colleague will help me. The last question is how we can export segmented data, which is the ROI, or we can convert ROI to mesh. We could export that as images or as a surface mesh, which is normally STL file. For COMSOL and Abacus, for that finite element analysis, they normally use solid mesh, which is not supported now by the current Dragonfly version. We are working on that. I'm not sure. Maybe maybe next version or maybe next year, we will support the exporting of the solid mesh. But now we don't have that tool, that function in Dragonfly. You have to use another software, which is many options, the open source or some other commercial softwares. They can convert the surface mesh to a solid mesh. It's a common question for us, but we don't have a solution for now in Dragonfly. As I said, in the future version, yes, but now you have to use something else to do that. All right, I think that's all for today. Thank you everyone for joining us, and see you next week. Bye.